Welcome to this webinar where we explore how a small Danish port is setting the stage for a global green revolution. The CONVEY project is transforming Hirtshals into a hub for green hydrogen and could become a model for sustainable ports worldwide. Our guests today are deeply involved in this groundbreaking initiative. Heidi, Program Manager at Norwegian Hydrogen, will share the vision and challenges behind the project, and Kari, Project Manager at VTT, will explain the technical innovations and how this concept can be replicated globally. To kick off our deep dive into the CONVEY project, Heidi, you will start by sharing your insights on the vision and challenges of building a green hydrogen hub. And after you, Heidi, we'll hear from you, Kari, who will guide us through the technical innovation and global potential of replicating this model. Yes, so Heidi, that was the introduction. I will leave it to you now. The stage is yours.
Thank you, Jacob. It's an honor to speak about the topic that's vital to the future of our planet, the transition to sustainable clean energy. I'm especially excited to share insights from the EU co-funded CONVEY project, which is an example of how maritime ports can act as hubs for green energy solutions. Before we dig deeper into the topic, let me briefly introduce myself and my organization. My name is Heidi Tuiskula, and the company I represent is Norwegian Hydrogen. We at Norwegian Hydrogen strive to develop renewable hydrogen production and refueling, for which CONVEY is a good example. Our first operational green hydrogen production plant in Norway is already serving customers for example, asphalt and steel production. And we look for more customer use cases in our current and future initiatives. Let us start with a simple question. Why green hydrogen? Well, the obvious answer when we talk about any renewable fuels or energy sources is the urgent need to fight the climate change. We all know we need to reduce the greenhouse gas emissions in all industry sectors with all means possible, and green hydrogen can be one of those. What makes green hydrogen interesting in this scenario is how versatile it is when it comes to use of it. It can practically be used for all the industry sectors to reduce CO2 emissions. In the CONVEY project, we will pilot the use of green hydrogen in transport and industry, replacing the traditional energy sources. Obviously, our location at port provides us an interesting opportunity to further expand the use cases. Looking at the two previous slides, green hydrogen has an opportunity to be a significant contributor to reaching our decarbonization needs by 2050. If we would produce all hydrogen needed by 2050 through electrolysis instead of steam reforming it from natural gas, it would save 1.2 gigatons of CO2 per year. Obviously, this will not solve the whole problem, but it is part of the puzzle we need to tackle global warming. This brings me to an important topic when we discuss hydrogen. The colors do matter. As I mentioned, at the moment, most hydrogen used is produced as what is called gray hydrogen, which is obviously equally emission-free when used in application, like a truck or a ship. However, producing gray hydrogen creates emissions, so if we replace traditional fuels with hydrogen to reduce emissions, we should focus on green hydrogen, which is produced from water. The electrolysis is powered by renewable energy. If we look then how green hydrogen is produced, here you can see an example of a PEM water electrolysis process in which water is broken to hydrogen and oxygen via renewable energy, electricity. Acronym PEM refers to the polymer membrane, which is used as an electrolyte in the process. This process uses approximately 9 liters of water to produce 1 kilogram of hydrogen and 8 kilograms of oxygen. In addition, it is possible to utilize excess heat from the process. To put the water consumption into perspective, the production of the jeans many of us wear needs 9,000 liters of water, 4,000 liters of water. Now we have discussed about hydrogen in general. and how, if produced via electrolysis using renewable electricity, it has tremendous potential to decarbonize various industry processes. Let us look next how we at Norwegian Hydrogen have already made it into reality. Hellesylt Hydrogen Hub, located in the Geiranger Fjord, is our first operational green hydrogen production facility. It has a capacity of 3 megawatts, and we can produce approximately 1.3 tons of green hydrogen daily. On this slide, you can see how the facility looks like, quite a beautiful background in the fjord. In addition to production, there is a VTT and hydrogen refueling station on site, serving heavy transport customers with green hydrogen. When we built this, we first thought we will produce green hydrogen for the local needs, like for various vessels operating in the Geiranger Fjord. But we have noticed that green hydrogen is actually a very attractive product, even for long-distance deliveries, around 400 kilometers to our customers in Sweden and 900 kilometers to our customers in Finland. If we look at the last year in Hellesylt, we started with hot commissioning, meaning commissioning with hydrogen in the system last June. And already before our grand opening in September, we were delivering to our first customer, Veidekke, who uses green hydrogen in the asphalt production process. You can see our 20-foot containers in the picture. They take approximately 450 kilograms of hydrogen each. If we look at the 3 megawatt production plants, from a commercial point of view, these should be remotely controlled, obviously. And this was our goal from the beginning. However, operating an electrolyzer plant is more complex than most expect. So we wanted to start safely the operation with having people on site to make sure that all our procedures for operation, including all the safety procedures and the technology together with those works. Nowadays, we can also produce remotely, but we have also engaged with the local community, and we have person available for regular maintenance and activities on site. On our first winter during operations, we have experienced some challenges, and we're constantly investigating the effect cold climate has on operations. Now we deliver with multiple types of containers to our customers across Nordics and have sold out most of the capacity already. This tells us green hydrogen demand is growing and more production is needed. This is very good news for the CONVEY project and the future of the green hydrogen market. Finally, let us dig deeper into the CONVEY project, taking benefits of the lesson learned in the Hellesylt project and expanding the scope of it. The CONVEY project is based at Port of Hirtshals in northern Denmark, where we are building a closed-loop ecosystem powered by green hydrogen. Our aim is to leverage local renewable resources, in this case wind energy, to create a sustainable cycle of production, use and byproduct integration that can benefit the port and the surrounding community. So, why ports are significant to us as green hydrogen ecosystem developer? I would say it comes to a few aspects. First of all, ports as industrial areas with various stakeholders involved make a perfect showcase for green hydrogen use cases. In most ports, you can find various industrial actors as well as full range of transport modes. This provides a great customer base for green hydrogen producers and refueling infrastructure developers. Then when it comes to replication, in Europe only, there are over 1,200 ports, thus demonstrating a solution at port gives a huge replication potential. Here you can see the timeline of our 5-year project. During our first year, we have been focusing on modeling and design aspects, as well as stakeholder engagement and business development. The coming 2 years are going to be important as we move from paper to real implementation. And as we all know, this is both demanding and exciting phase in the project. During the final years, we will be in operation testing the solutions, business models and looking for replication opportunities. We all know it takes a village to raise a baby or to build a new market. This is why we at Norwegian Hydrogen are not doing the project alone, but together with our partners. Port of Hirtshals, supported by Greenport North and Hirtshals Transport Center, are obvious partners, providing us access to the pilot location itself. Norwegian Hydrogen, with our daughter company Videon, are providing the hydrogen infrastructure and services, whereas SCADA International is looking at developing a tool for energy management at the port. Our customers, Biomeca, Honest, and Vendepool Spedition, are key to our success, being the frontrunners this industry needs. VTT, as our research partner, is focusing on both the technical ecosystem modeling as well as leading the business model development work. And finally, our partner Hydrogen Valley is helping us spread the story of Hydrogen Valley in Port of Hirtshals and help us replicate it further. At the heart of CONVEY is a 5 megawatt electrolyzer powered by wind energy, which produces green hydrogen. This hydrogen has two specific offtakes, industry and transport. The industry use case includes a food supplement producer, Biomeca, located in the Port of Hirtshals, right next to our facility. And their aim is to replace the use of natural gas in their burners with green hydrogen. Transport use case includes our daughter company Videon building a green hydrogen refueling station for heavy-duty transport customers in connection to Hirtshals Transport Center, a logistical hub for all transport between Denmark and Norway. Vendepool Spedition, a Danish logistic company, will invest in hydrogen-powered trucks to refuel in our station. The byproducts, oxygen and heat, are repurposed in an innovative land-based trout farm established by our partner Honest. Through this circular approach, the project expects to produce more than 550 tons of green hydrogen yearly after entering into operation, directly reducing carbon emissions associated with conventional energy sources. In addition, it will produce over 4,500 tons of oxygen and quite a lot of heat to be used in the port. Our ultimate goal is to make ports like Hirtshals an integral part of Europe's green energy transition, showcasing how local renewable resources can be tapped efficiently. Successful piloting of green hydrogen production at the Port of Hirtshals has significant market potential for scaling up and replication, especially in the maritime transport sector, where the demand for sustainable fuel solutions is growing rapidly. Ports are pivotal in accelerating the shift to cleaner energy sources for ships, ferries, and other vessels. By establishing green hydrogen infrastructure at the port, CONVEY not only decarbonizes businesses at the port, but also lays the groundwork for broader maritime transition to cleaner fuels. Obviously, we need to understand that the production we will build during the CONVEY project will not be sufficient for the needs of the vessels visiting Port of Hirtshals, but it is a start and it brings opportunities to scale up further. In conclusion, CONVEY is not just a project for today, but a model for the future, illustrating how ports in peripheral regions can lead in the green transition. By producing green hydrogen and making it accessible to maritime and other heavy industries, we hope to inspire similar initiatives across Europe, reinforcing ports' strategic role in a sustainable decarbonized economy. Thank you for your attention.
Thank you so much, Heidi. I was just typing some questions, but we don't have time for all of them. So if I had to choose one of them, it would be, you mentioned this 5-year plan. What are, the biggest challenge for the CONVEY project over the next 5 years? The biggest, maybe.
I would say the biggest challenges are obviously we are building a very expensive technology, very new technology. We are integrating multiple different businesses which have their own business needs, obviously, and goals. And we're trying to do this all in a very tight timeline. So that's the whole integration. I would say whenever you do any novel technology, the integration part is the difficult, whether it's the integration of the businesses or the integration of the actual technology.
Yeah. All right. Thank you so much, Heidi and Kari. The stage is yours now. Could you maybe start by introducing yourself?
So yes, so my name is Kari Mäki. I'm with VTT, Technical Research Center of Finland. I'm a research professor for smart energy systems at VTT. And yes, also leading this CONVEY project from our side, of course, together with my colleagues. VTT is basically, as I said, research institute. So we are working on more or less all fields of technological research, very much on the applied side. And we are also very proud to be part of CONVEY. But today I will actually speak about the sector integrated energy system model we have been building for the CONVEY case that was already presented. So just a moment, yes. So the agenda is pretty simple. I will start a bit with the sector integration topic. So I will talk a bit about why to integrate different kind of energy vectors, for instance. Then we come to the CONVEY case exactly. Have a look at the modeling approach we used. Have a look at some first results based on our studies, and then conclude pretty briefly. But I would like to start with sector integration, which is kind of the key interest for us also in this CONVEY project from our point of view. So, and maybe starting from what's happening actually on the energy system side, and what is our vision for the integrated energy system for future. So there was already something mentioned about the decarbonization needs, of course. So basically, energy system at the moment is facing a lot of challenges, and is also like a key driver, key enabler for the transition that is ongoing. So basically at the moment we are decarbonizing everything, and that's very important work as such. Of course there are things like industrial processes, mobility and transport, heating options that are kind of maybe the most important ones. But this happens, decarbonization happens basically everywhere at the moment. At the same time, of course, we need to maintain like a reliable and cost-efficient system so that also the price will remain reasonable. At the same time, we have a lot of like new digital options. Data is there, connectivity. We can control a lot of things. So that's something we want to apply. AI can in future help us a lot in this kind of complex decision making, for instance. But maybe the most important thing is that the way the value actually builds is pretty much evolving. So there are new kind of things. For instance, energy is not the only thing. I mean, in terms of kilowatt hours or megawatt hours, it's also about when you're using the energy, and that means what is the power you're actually taking and how you are timing that. So that's also something. So that will be important for the future as well. And then there are a lot of like new circular models, so that there will be different kind of stakeholders, different kind of energy carriers, different kind of sectors together, just as we see also in the CONVEY case. And then the value is being built in a new way. So this kind of integration across different sectors, applying hydrogen, power to X processes, industrial processes, storages, whatever. This is really the key for the future from our point of view. And I will just take this is also a nice picture about the same thing. But I mean, when we think about the future energy system, the point is that somehow the starting point for everything is that we have clean electricity generation. So we have, as we have here, wind, solar, hydro, even nuclear. So we have different options. Then we are pretty much, of course, directly electrifying different things like mobility, industry, putting heat pumps in the buildings and so on, and that's important part of it. Another important part is of course that everything cannot be electrified, and also the electricity side will have some kind of bottlenecks. So hydrogen is really a valuable option there. Also like a means of storing the clean energy and a kind of a buffer, and that's exactly for the industrial processes, for instance, very good option. So, but basically we will have side by side electricity, heating, hydrogen, maybe some other options as well, and they need to kind of play nicely together, so to say. Okay, this is a bit like maybe repeating, so I'm not going into all the details. But what is actually important here is this is exactly the focus on the sectoral interfaces. So what are the points in which, for instance, electricity and heat, or electricity and hydrogen and heat come together, and how can we optimize in these points? That's really like an interesting aspect from the research point of view, but also for the practical applications. Another thing is that data sharing. Data is there, so we can be real much like aware of what is happening, and we just need to be able to exactly share the data better. So what we want to gain out of the sector integration then is to be able to look at like a higher level optimums rather than very local sector specific sub-optimums. We want to see how the whole system, like exactly like Hirtshals in Convey, how that can be optimized rather than one specific unit within that area. That's an interesting thing. Then we are of course looking at the flexibility potential across the sectors. So if there is, for instance, hydrogen storage, hydrogen buffer, so what can we do, for instance, towards the electricity market if there are like a price variations or even some kind of disturbances on the electricity side? So how can we kind of interplay in that case? So a lot of this kind of synergies we are looking for. But then I will actually come to the Convey ecosystem, and as I said, Convey is exactly demonstrating this kind of a sector integrated energy system, and this is really an exciting case for us in that sense. You already saw this picture. I'm not wasting time on this. It's an interesting area. The ecosystem that is being built can be simplified like in this picture. So, and maybe the most important thing there is that there will be hydrogen, heat, oxygen side by side, and there will be like 3 different carriers in this sense. Of course, electricity is also there, and that's also one important thing. But these 3 carriers are somehow like an outcome from the electrolysis, which is producing the hydrogen. And on the top of that, we have, of course, there will be energy management system. There will exactly be different kind of data sources and data management and so on. But to me, this is exactly the core interest within the sector integration, how to play these different sectors side by side. And so what we have done at VTT, so we have been modeling the whole case. We have been using a SpineOpt tool. On the right hand side, you can see a bit like how the model looks like. It doesn't need, I mean, this is not meant to be so that you could be seeing some details out of this, but just to give some kind of overview of how it looks like. So there are different kind of components, and we have been trying to model the whole system as good as possible. And of course, there are like 3 purposes for this. First of all, we want to optimize. So we want to find the optimal parameters and combinations in this kind of environment where there are a lot of different kind of variables, let's say. So this is maybe the key purpose for this kind of a model. Of course, it supports us for doing technical and economic analysis, also taking into account different kind of tariff structures or markets and so on. And but at the same time, we can also model the key components like electrolysis and other things into a detailed enough level to get a good understanding on what are the choices and how they interact and so on. So what we actually started with in CONVEY was like a really wide data collection for actually everything that is happening on the site. So for wind power output, for electrolyzer, for different kind of these industrial off-taker applications that were mentioned in the also by Heidi about the infra and about everything more or less. And especially we used a lot of time to understand the off-takers, what are their needs, what are their profiles, because this is one really important aspect here, is to be able to match the supply and match the need and see how the profiles fit together and whether there is a need for storing and so on. So and of course it's so that the model can only be as good as the data we start from. So in this sense, the data collection has been really important. And now that we have the model running, of course, we are still able to improve it all the time by more parameters, better data, and so on. And from now on, this is our tool that we are using for the CONVEY project. And if I didn't mention, this was modeled by the SpineOpt tool, which is like an open source tool as such, and this is quite commonly used by VTT as well. So just to go a bit more into details, if you think about the optimization problem we are looking at, so we are formulating this as a cost minimization problem. So we are putting like a cost for everything that will be done there. And now we started from like 1 hour steps, and then we actually progressed into 10 minutes resolution, which allows us more dynamics also within like intra-hour dynamics in the studies. But it's still like it's not like a fully dynamic simulation in a sense, but it runs through the whole year in this kind of a resolution and looks for the best options, so to say. And also in the picture, you can see different kind of components we have been modeling, different kind of grids or carriers we have been modeling. So you can see different colors for electricity, heat, hydrogen, oxygen. And this is really, really, as I said, an interesting case in the sense that everything depends on everything. What is the heat supply need on different parts of the system, or what is the oxygen supply need, and how things should be dimensioned and this kind of. So it's really like a multi-dimensional system and very interesting one. So with this model that I was showing, I wanted to pick up some like an example results. Of course, we are not. We are working on it all the time, and as I said, we are getting more and more out of it as we get more data, and as we kind of still improve the model. But we have definitely completed the first runs, and we have good result data already available. So just like some examples, for instance, the economic value. So we were looking at different kind of options, like first of all, how much hydrogen will be produced. On the other hand, what is the offtake level, and we were looking at the economic value for the whole system under different assumptions then. And you can see that on an annual basis, the economic value potential is something like in the minimum case, something like 1.5 million euros. In the best case, even more than 3 million euros. Of course, that's for the whole system. So that's then something that is kind of shared across the stakeholders, depending on the business model, for instance. But the point here is that the system would be kind of more cost efficient to run, and there would be a clear economic value behind that. Another example, of course, a very important indicator for us is that we are avoiding CO2 emissions with this kind of setup. Again, we had different kind of scenarios, different kind of hydrogen demand levels, and then we were looking at how much emissions we are avoiding on the annual basis. And of course, it's quite obvious that the more green hydrogen we are able to use, more emissions we are avoiding. I guess that's kind of clear. But then it's also interesting to see different colors. So according to our scenarios, certain part of that comes from the transport, certain part comes from the industrial side, then from heat as well. So you can see that the industrial use is maybe somehow dominating in this case, but there will be improvements on all these sectors. And I guess, yes, there is also another way to look at the avoided CO2 emissions. So again here, we are looking at the achieved emission reductions under different kind of hydrogen supply conditions, and on the other hand, wind conditions. So you can see that we have on the x-axis we have different kind of wind conditions from the minimum case to maximum case, and then we have different kind of supply and demand options there, and then you can see the range of different cases. The black dot is kind of our baseline case, so that's what we are kind of assuming, but it could be even better than that. Yes, I just wanted to conclude very briefly, actually a bit repeating what I was already saying, but also kind of highlighting the key points. So I started with the sector integration story, how that offers an important approach for synergies and flexibility across sectors. This is really an interesting development, and this is what is also realized in the CONVEY ecosystem. And then this modeling work I was presenting, this supports analyzing and optimizing this kind of complex systems. So even though we have the cross-sectoral situation, we have the exciting case with the oxygen also there. So this is a really interesting modeling case, and we have the model now up and running. We are able to look at different kind of options there. So altogether, CONVEY demonstrates a new circular concepts, and this can really be replicable across many similar locations. So we also have some business model related activities ongoing, and we are looking at similar ports first of all, but then also different kind of areas where the same concept could be brought in. And actually what we have modeled, for instance, that's really applicable on a wide range of different kind of areas and cases. And somehow the model is also so that we can use different kind of parameters, look at different kind of cases, and be really efficient in that sense. And yes, I was also showing the first results. They already indicate clear benefits for the economy, for the emissions, and of course there is much more result data behind, a lot of analysis on different components and so on. And this will be, of course, there will be more results later on, and the work continues here. That's more or less my part. I just wanted to also end up with the project partners slide that was already earlier there. And thanks for this. Maybe it's back to Jacob.
Thank you, Kari. I also have I have a lot of questions, but if I have to choose one of them, for us who are not an expert like you, could you try to explain what you see as the most critical innovation or breakthrough needed to ensure this model's scalability and success across other ports? Do I have a short answer for that?
Yeah, exactly, because that's also like a systemic question in
Yeah.
a sense. I mean, we have the basic concept is such that you can apply it in many places. So you have hydrogen, heat, electricity, industry, everything. But at the same time, we need to look at what kind of industry, what are the profiles, what is the need for storage. So I guess it's maybe exactly the challenge here is that it's a systemic thing. So we need to be ready to look at different kind of parameters and how they fit together. Yeah. But I guess the one simple answer is the same that Heidi was already giving. So the hydrogen is in a central position, and that's like a new technology. So maybe that's still the most challenging part of it. But then modeling the whole system is also something that is some kind of an effort as well. So
all right. I just think I will say thank you so much, Kari and Heidi, and thanks for watching this webinar. I know it wasn't live; we had some technical difficulties, but here we are. And thank you so much for watching. And thank you again, Heidi and Kari, for sharing your valuable insights into the CONVEY project and the exciting potential of green hydrogen. We're looking forward to see how the CONVEY project evolves over the next 5 years. There was this 5 years plan, Heidi, which you told about. And just thank you for this part and thank you for this conversation. And until next time, thank you so much.